so to talk about example 4, if I were to multiply this out, this squared would make this 2x 4x squared times x 4x cubed. Half of that is 2x cubed. And then at the end, a negative 3 times a negative 3 is 9, times 1 is 9, times a half is 9 halves. So I could tell by looking at just the first terms and just the last terms what the end terms are going to be. I have no idea without doing extra work what the middle terms are going to be. So we see here that the degree is 3. Since this is positive, the right hand goes up. That's how we say right, and that's how we say up. Since the degree is odd, that means the left hand goes down. It's the opposite of the right hand. The negative 1 from the x plus 1 and the 3 halves from the 2x minus 3. Since the x plus 1 appears once, multiplicity of 1, it crosses. The 2x minus 3 occurs twice, multiplicity of 2, so it bounces there. So using that information, right hand goes up, left hand goes down. At 1.5 it bounces. At negative 1 it goes through, and it also has to have a y-intercept of 9 halves. Example 5, this squared will make this x squared, this cube will make this x cubed, it will have this negative 4 in front of it, and so I have negative 4x to the 5th. Looking at the last term, I have here 1/2 squared is a 4th, times a negative 4 is a negative 1, and negative 5 times negative 5 times negative 5 is negative 125, times the negative 1 we just mentioned, and so the last term is going to be positive 125. The leading coefficient is negative, so the right hand goes down. The exponent is odd, so the left hand goes up, the opposite. The first term gives us the negative, with the first factor, gives us a negative 1/2 with multiplicity 2. So it bounces there. And the second one gives us a 0 of 5. It's cubed, so it has multiplicity 3. It's odd, so it crosses. So I would find the intercepts. I would find the y-intercept. I would start with the right hand going down. When you come up, since it's third degree, it comes through like an x cubed. Then it goes up to the y-intercept. It comes down. It's going to touch at negative 1/2 and go back up. So the left hand does in fact go up. Everything matches. This one, x is squared, times another x, x cubed. Negative 2 would be in front of that. For the last term we have 2. Negative 1 squared is 1, so 2 times 1 is 2, times negative 2 is negative 4 for the last term. I get the last term because if I set x equal to 0, the last term is the y-intercept. Since the leading coefficient is negative, the right hand goes down. Since it's odd, the left hand goes opposite or up. 1 appears twice, so it bounces there. Negative 2 appears once, and so it's going to cross. Again, to graph these, what I would do first is just put the 3 dots for the intercepts, and then start with the right-hand side that goes down, come up. If I have to touch this, I go back down, I go through the y-intercept, and since I cross this one, I go up, and sure enough, the left hand goes up. A little more going on here. This -1 will give us a factor of x plus 1. This x-intercept of 2 will give us a factor of x minus 2. And this 0 of 5 will give us a factor of x minus 5. Now, the right hand's going down, so I need a negative number in front. And so here's a silly comment, but maybe it'll help. If you want an A for the class, always put an A in front and look for it. So here's what we'll do. This point is also on the graph. It's the point 0, -5, which means if I plug in x equals 0, I should get -5. Plugging in 0 here gives us 1. Plugging in 0 here gives us -2. Plugging in 0 here gives us -5. And so I get -5 equals 10a. Divide both sides by a, I'll get -1/2. So if I go back, rewrite this whole thing, but put a -1/2 in front, I'll have the function that has these 3 x-intercepts and also the correct y-intercept. Same thing here. This x-intercept of -3, and it bounces, so it appears twice. It goes through -1, x plus 1, and then it goes through 1 like a cubic, a 3rd degree, so it's x minus 1 cubed. And again, because we want an A for the class, let's put an A in front just to be ready for the next step. We see that the y-intercept is -3, which means when x is 0, y is -3. This becomes 9. With a 0 here, this is of course 1. With a 0 here, that's -1. And so I multiply it out, and I get -9a equals -3. Divide both sides by -9. I get a as 1/3. It's positive. Good. The right hand goes up. It's supposed to be positive. So let's put the 1/3 here. Keep everything else, and we're done. For this last question, we have everything to talk about. Domain, it goes forever to the left and right. Range, the bottom is here, and so that's at -20, and it goes up to infinity. Since I have 1, and then there's 3 here, that's 4, 5, 6. The degree here is, let's fix this, it's 6. Because we have multiplicities. Since the right hand goes up, the sign of the leading coefficient is positive. So the end behavior, the right goes up, and the left also goes up. Left and right is x, up and down is y. Turning point here is -4. Turning point here goes from increasing to decreasing. That's at about 3 1/4. And here it goes from decreasing to increasing. It's a little more than 6. Whatever you want to write there is fine. Now for the inflection points. So here, we're driving the car, making slight left turns to stay on the graph. Then we make a sharp left turn, and about here, we start turning right. Turn right, turn right, turn right to about there. And then at that point, we start turning left again to about there. And then we start turning right again. Sharp right, turning right, turning right, turning right. Get to about there, and we start turning left again, because we have to set up for this turn. Then a sharp left, and then taking a left, slightly, 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 on forever. So the change from turning left to turning right occurs there, occurs there, occurs there, and occurs there. So we have these 4 inflection points at -3, at -1, at about 1.5, and a little past 5. So let's jump down to K and L. The concave up is where the graph is green, and I'm making left turns, and the cave is going up. Then I make right turns, and the cave is going down. That's concave down. Left turns, the cave is up. Right turns, the cave is down. Left turns, the cave is up. And so those regions are where it's concave up and concave down. And then the old-fashioned increase and decrease is separate. When I'm going down, it's decreasing. When I'm going up, it's increasing. I think you can follow that on your own. But the concave up, concave down, and inflection points, that's new. So I want to spend a bit more time on those.